Hey, what's up guys? This is a video for section 10.2. We are going to simplify radicals expressions, and we need to know what is a radical first of all, and then after we know what's a radical and a radicand, we are going to be able to simplify a radical or a square root in this section. So let's go ahead and look at the vocabulary first. Radical is the symbol that you guys already know as the name of square root. Inside of the radical, the number, the name of it is radicand. So you guys can ask for the square root of 4, the square root of 16, the square root of 100, or the square root of 7, the square root of 17, any number. But we do have the square root. Now, why do we say square root? The word square means you are going to multiply a number 2 times, and it will give you guys the value of the radicand, the number inside of the radical. So I'm just going to underline the word squared here so you guys remember. This means you multiply a number by itself 2 times to get the radicand. So let me give you guys an example, and you guys can see the bottom here. Kind of ignore this side of the equation, the equal sign right here. We're going to talk about that exponent and 1/2. But if you look at this, the square root of 4, well, the answer is 2, because if you multiply, and I'm just going to put 2 numbers here, 2 times 2, that equals 4. It equals the radicand. So the square root of 4 is 2, not 4. It's not the square root of 2. It's just 2. Because if you multiply that number by itself, you will get 4. And you multiply 2 times by itself. All right, now, what do we need to also learn with radicals? When you guys look at exponents, remember that we have 7 different properties of exponents. We can also have exponents as a fraction. Now, those exponents as a fraction is when you are looking for a root. Now, let me explain what I mean when I say root. Notice right here, I have the square root of b is the same thing as b with the exponent of 1/2. Now, the radicand, the number inside of the radical, when you change that to an exponent, or you have an exponent, the radicand becomes the base of the exponent. The number on the bottom of the fraction, so here's the exponent 1/2, this number 2 is the root that you are looking for. So if you have a 2 as a denominator, you are looking for the square root. So if I'm saying square 2, then we can also have a cube root, which is 3. And we can have a 4th root, which is 4. And we can have a 5th root, 6th root. So what I'm saying is we have more than one kind of root. Yes, we have the square root, the one you guys learned in junior high. But we also have other roots that you guys can find. So your exponent 1/2 represents the square root of the number. So you might see the radical in a problem, the square root of 16, just for an example, or you guys can have 16 with the exponent of 1/2, and they mean the same thing. You are looking for the square root of 16. When you guys look for different square roots, here's an example. The square root of 64 is the same thing as 64 to the 1/2 power. Over here, we have the square root of 4 is the same thing as 4 to the 1/2 power. The square root of 81, we know the answer is 9, because 9 times 9 is 81. So 9 is the square root of 81. But when you change that with an exponent, you can write it as 81 to the 1/2 power, or the exponent of 1/2. So we say that this right here is a radical form because it has a square root, radical. And this one here is called an exponential form. Exponential, you guys can hear the word exponent in that, exponential. So this is an exponential form, and this right here is your radical form. So I'm going to show you guys how to simplify radicals. And sometimes, a few problems, we have an exponential form. The exponent will be 1/2. But we're also going to simplify that. So let's go ahead and look at some examples. With the examples I'm going to show you guys, you also need to know a couple of properties. So let's look at a couple properties here. Property number 1 says if you have radicals, when you are multiplying radicals, I'm just going to show you guys right here. When you're multiplying radicals, let's say you have the square root of 4 times the square root of 5. I'm just making up numbers. If you're multiplying, you can put them together in one radical. Now, one thing that you guys notice is the little n outside of the radical. When you guys have a little number outside of the radical, that number is telling you the root that you're looking for. Remember that I mentioned we have different roots. We have a square root, which means 2. We have a cube root, which means 3, 4th root, 5th root, and so forth. So you might have a little number outside of the radical with a 3, or with a 4, or with a 5. Now, if you don't see any number, there's an invisible 2 outside of the radical. So that's why we say every time we look at the radical is the square root if there's no number outside. So this one here is the product property. When you guys are multiplying two numbers inside of the radical, you can multiply those two and you can separate them with the same radical, or you can go back. If you have two radicals, you can put them back as one. The next property, quotient property, is when you have a fraction. And the idea is the same thing. If you have a fraction inside of the radical, you can separate the fraction with the radical on the top and the radical on the bottom. Notice we have one radical here. Now we have two. Or you guys can go backwards. You guys can make, from two radicals, you can make one and keep the fraction inside of the radical. Now in these cases, b cannot equal 0, so we're not going to have an undefined answer. You guys will have some number. So remember the two properties. And you guys can come back to the video, you can pause it, you can read what it says here, and you guys can learn the two properties. Something else that will help us though are the perfect square numbers, okay? Now all of these guys is to simplify radicals. Now perfect square numbers and perfect cube numbers are very similar, but I'm just going to talk about perfect square numbers in this video. My next section we'll talk about perfect cube numbers. But perfect square numbers, if you guys notice the numbers I gave you, there's a list and there's actually 20 different numbers here. We have the 4, the 1, the 4, the 9, 16, 25, and so on, so on, so on, so on. I want you guys to notice what's happening to the numbers, or something that is very common for every number. If you look at the 1, the 4, the 9, the 16, well, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 4 is 16. So every number here has a perfect square root. You guys can find the actual square root. Two numbers that multiply to 49 and the same number, and you multiply twice, you get 49. It's 7. So the square root of 49 is 7. A number that you multiply by itself 2 times, it gives you 64, is 8. So that's the square root of 64 is 8. A number that you multiply by itself 2 times and gives you 81, 9. The square root of 81 is 9. So this is 10, 11, 12, 13. The square root of 69 is 13, 14, 15, 16, 17, 18, 19, and 20. 20 times 20 is 400. So all of these numbers are called perfect square numbers. Once again, the word square means 2 times. So it means that if you multiply a number by itself 2 times, you guys will get these numbers here. If you can identify those square roots or the perfect square numbers, you guys will be able to simplify it a lot faster, the radicals. So it's a good idea to memorize the numbers and understand which one are perfect square numbers. Not every number is perfect squared, so that's when you have to use another method to simplify if they're not perfect square numbers. Perfect cube numbers, like I said, guys, very similar, but I'll talk about that on my next section. Now we are ready to simplify some radicals. So let's look at these examples right here. Notice, first of all, we do have radicals. We have exponents of 1/2 right here. We have a radical and we have an exponent of 1/2. We want to simplify and give an exact answer with a radical in every problem. Can you guys use a calculator and find the square root of a number? Yes. But if you do that, first of all, it will give you guys a decimal if it's not a perfect square number. And every time people write the answer as a decimal, they round. So that's not a perfect number or a perfect answer. It's not an exact answer. So every time you guys round to the 10th or the 100th place, you are approximating. We want the exact answer. So we're not going to use a calculator, but we are going to use radicals to simplify. So let's look at the first example here. We have the square root of 56. So how do you guys simplify the square root of 56? I don't want you guys to approximate. Do not look for an approximation. This is what you do. And there's a couple of ways you guys can actually simplify a radical, but I'm going to show you guys one that I like, and I see my students get this method faster than the other ones. So 56, first of all, you want to find two numbers that multiply to 56, and you want to break down the number. What we're going to use is called prime factorization. So just two numbers that multiply to 56, and I can tell you guys right now, 7 times 8 is 56. 7 is a prime number because the only factor of 7 is 1 and itself, 7. There's no other factor, other number that goes into 7. So that's a prime number. 8 is not prime because you can break down the 8. You can break it down to 4 times 2. And 4 is not a prime number because you can break it down to 2 times 2. Now, 2 is a prime number. 2, 2, and these 2, those are prime numbers because the only factors are 1 and itself. So now you are ready to write your answer. After you break down the number 56 as a prime factorization, you guys are going to keep your radical. So there's my radical right there. Notice we have an invisible 2 outside, so this is the square root. I forgot to mention that at the beginning. So there's an invisible 2 right here. I'm just going to write it down so you guys can have an idea what I'm talking about. So invisible 2. 2 means square root. You might have a 3. Next section you will have a 3, so that's a cube root. But right now we're looking at the square root. Now you guys will go to your prime factorization. So we have a 7 when we broke down the number times 2 times 2 times 2. When you multiply all those numbers, it will give you guys 56. 7 times 2 times 2 times 2 is 56. You must look for pairs. So I can see that I can make a pair right here. This 2 and 2, 2 times 2, there's 2, that's a pair. The 7, you cannot make a pair. This number 2, you cannot make a pair. There's no other 2. Not these 2, we already used these ones, but there's no other ones to make a pair with this one. So the pair, the number with the pair will go outside of the radical, and you guys write it down how many times you have the pairs of. So let's say we have a pair of 1. We have 1 pair of 2s. So what that is, you are going to write down the 2 one time outside of the radical because we only have 1 pair. The numbers with no pairs, they will go inside. So this 7 goes inside right here, and this 2 goes inside of the radical, and you guys are going to multiply those 2 numbers inside of the radical. So we have 2 square root of 14, and that's my answer. My exact answer of square root of 56 is 2 square root of 14. You simplified the radical, not a decimal. We didn't use a calculator. You're not approximating. That is the exact. Can you guys use a calculator and find out what decimal form this is? Yeah, you can. But remember that we're not looking for the decimal form. We're looking for the exact answer, the radical form. And I'm saying radical because it has a radical. Now the next one, 52 to the 1/2 power. First of all, you have to remember what the exponent is, 1/2. This exponent means square roots. So 52 to the 1/2 power is the same thing as the square root of 52. And I want you guys to do that. If you see the exponent of 1/2, change it. Use the square root, the radical. So now we understand that we're looking for the square root of 52. So I'm going to look for two numbers that multiply to 52. So if you guys don't have an idea, you can look at the number. I notice this is even, so I know 2 has to go into 52. So I'm going to start with 2. It's okay to start with 2. So 2 times 26 is 52. And this is where you guys have to check. You have to multiply. But you have to make sure that you multiply to the radicand. Now 2 is prime, so you cannot do anything there. But the 26, you can multiply by, you can multiply 2 by 13. 2 times 13 is 26. Now guys, 13 is prime because the factors are 1 in itself. 2 is prime, 2 is prime. So now I'm going to look for my pairs. So I can make a pair right here. You guys see those numbers? The 2's, 2 2's, that's a pair. 13 is the only number we have. So that is not a pair. So now you guys write down your radical right there. The pair of 2's goes outside. Now we only have one pair, so I'm going to put only 1 2 outside. There's one pair of 2, you put 1 2 outside of the radical. And the 13 doesn't have a pair, that one goes inside of the radical. And that is my exact answer, radical form, because you guys have the radical. And remember guys, the pairs, they go outside of the radical. The numbers with no pairs goes inside of the radical. Now this one here, you guys have a number outside of the radical, the 2. And you have the square root of 72. Remember that when you don't have anything in between the variables or the numbers, in this case we have a radical, it's the same thing. If you don't have anything in between, you are multiplying 2 times the square root of 72. If you have a plus in between, you're adding. If you have a minus in between, you're subtracting. But right now we're multiplying. So the number outside of the radical, you are not going to break that number down because it's already outside. You only break down, you use prime factorization for the numbers inside of the radical. So this 72, I know that I can multiply 9 times 8 to get 72. Can you use other numbers? Yeah, you guys can. For example, 2 times 36 is 72. But right now, I'm going to use 9 times 8. Now, I know 9, we can break it down to 3 times 3. And the 8, we can break it down to 2 times 4. The 4, you guys can break it down to 2 times 2. Okay? That's it. We don't have any other number that we can break down. So now I'm going to start making pairs. So the 3's, I can have one pair right here. 3 and the 3, that's one pair. The 2's, I can have a pair right here, 2 2's. And do not forget this one here. This one is by itself. You cannot make a pair with this one. But we have a pair of 3's and a pair of 2's. So now you start with the radical. Here's the radical. The pairs, they go outside of the radical. So the 3 goes outside, the 2 goes outside, and you're going to multiply. Now, there's one pair of 3's, only 1 3 outside. One pair of 2's, only 1 2 outside. And this one right here is going to go inside because that one doesn't have a pair. Something else. You guys remember the 2 outside of the radical at the beginning? You guys need to bring it down. So I'm going to bring down the 2 outside of the radical, and I'm going to multiply by the numbers outside of the radical. So now you multiply 2 times 3 times 2, and that's going to be 12, and we have the square root of 2. So there is my exact answer. You guys have the radical form. You guys use prime factorization. Now the next one here, 245 is a big number, 245, but don't worry guys, I'm not going to give you guys huge crazy numbers like 2,580. I'm just going to give you guys some 100 numbers, and they're going to be doable where you guys can break down the number. Now remember, 245 to the exponent 1/2. Keep in mind, the exponent of 1/2 is the same thing as the square root. So I can change this to the square root of 245, and I want you guys to do that. If you guys see the exponent 1/2, change it. Use the radical, the square root. Now you guys are going to break down the number. I noticed the number ends with the 5. So any number that ends with the 5 or a 0, 5 goes into it. The factor is 5. So I'm going to multiply 5 times 49, and that is 245. 5 times 49. Now, 49, you guys can break it down to 7 times 7. Guess what, guys? We have a pair of 7s. So now you are, and 5 is a prime number. Prime 5, you guys cannot break that one down. So now you guys make a pair of 7s. I'm going to have my radical here. 7 goes outside because there's a pair, one pair, only 1 7 outside of the radical. And the 5, no pair, it doesn't have a pair, you put it inside of the radical. So my answer, exact answer, is 7 times the square root of 5. That is my radical form. Once again, you guys can use the calculator to find out what the decimal form, but we're not looking for decimals. We are looking for exact answers, radical forms. Now, this example here, notice that we have two different radicals, and you are multiplying the radicals, and you want to simplify every radical. Now, we also want to give the exact answer. We want to find that radical form, not the decimal, but this is where you guys have to use one of the properties that I show you guys at the beginning of the video, which is the product property. If you guys are multiplying two radicals, you can make one by multiplying the radicands. So you have to understand what the radicand means, what the radical means. So radical, we know that's the symbol, the square roots. Radicands are the numbers inside of the radical. So when you guys simplify, you are going to make one radical and you multiply the radicands. So let's go ahead and look at this example here. So I'm going to make only one radical. I am multiplying the square root of 2 times the square root of 14. So that's right there, one radical. And I'm going to multiply the 2 times the 14. Notice I'm only using one radical. So now I multiply the two numbers inside the radical. So that's 28. And I'm ready to break down the numbers. Now 28, you guys need to find two numbers that multiply to 28. Yes, we know that 2 times 14 is 28. You guys can use those numbers. But if you guys can find smaller numbers, I think it's going to be a lot easier for you guys to multiply. For example, 7 times 4 is 28. Hey, 7 is smaller than 14, and 4 is smaller than 14. And I'm talking about this 14 here. And you guys can multiply those two, 7 times 4, and it gives you guys the same number. 7 is prime, so you guys cannot break that one down. 4 is 2 times 2. So we can make a pair. Pair of 2's. So that's going to go outside of the radical. So all you do, guys, you keep the radicand. 2 goes outside. One pair of 2's, only one 2 outside. And the 7, this one doesn't have a pair, so you put it inside of the radical. So 2 square root of 7 is your exact answer. So let's try another one. Next one, you guys have the square root of 10 times the square root of 20. Well, let's make one radical right there. I'm going to multiply 10 times 20, and that's going to be 200. I'm going to find two numbers that multiply. Yes, you guys can use 10 times 20, and I'm going to use those two again. Another option is 100 times 2. You guys can use those two, but you guys can use any numbers that multiply to those numbers. So 10 is 5 times 2. 20 is 5 times 2. Nope, not 2. 5 times 4. Sorry. 5 times 4 is 20. 4 is 2 times 2. Okay, guys. So look, I have a 5 right here, 5 right here. That's one pair of 5. And I have a pair of 2's right there. Notice that this one here, remember this one? We didn't break this one down. So that one goes inside of the radical, and the pairs will go outside of the radical. So let me put the radical right here. So the pairs, 5, only one pair of 5, one 5 outside, and one pair of 2's, one 2 outside, and you multiply. Don't forget to multiply those numbers. And this 2 right here goes inside because it doesn't have a pair. Now you guys multiply, that'll be 10 outside and the square root of 2 inside, and there is your exact answer. Alright guys, now this one's here, you guys have numbers outside of the radical, you have actually radicands, you have two radicals multiplying each other, so we have 4 square root of 2 times 5 square root of 8. What you have to do when you multiply, guys, first of all, let's go ahead and make only one radical. So there's one radical. You are going to multiply the numbers outside of the radical, and you're going to keep them outside. 4 times 5. You guys are going to multiply the radicands. So the 2 and the 8, 2 times 8 inside of the radical. Outside, we're going to have a 20. Inside, we are going to have a 16. Now, you guys are going to multiply the 20 times the square root of 16. So first of all, let's find out what is the square root of 16. Well, two numbers that multiply to 16, guess what? 4 times 4. And 4 times 4, you guys can break it down to 2 times 2 and 2 times 2. We can make pairs of 2's. So this right here is a pair, and this one right here is a pair. So I'm going to keep my radical right here. I'm going to write down the pairs outside of the radical. So notice how many pairs we have. We have 2 pairs of 2's. So I'm going to multiply 2 times 2. Remember that you are multiplying these numbers here, just in case you guys forget. But you guys have 2 pairs, 2 2's outside of the radical. The 20, you guys have to bring it down. So this one right here. So you're going to multiply 20 times 2 times 2. And guess what? We don't have another number. Notice we broke down the 16 to put inside of the radical. So when you guys use all the numbers that you guys broke down, this radical, you guys don't need it anymore. So let me try to erase it. See, hopefully I can erase. And yes, I can. So you don't need that radical. If there's no number with no pair, that means you guys use all the numbers. So you don't need the radical. Now you just multiply 20 times 2 times 2, and that's going to be 80. So the answer is 80, no radical. That's it. Let me just put this a little bit higher so you guys can see the whole 80 right there. So let's do the next one. The next one, you do the same thing. You multiply the numbers outside and the radicands. So I'm going to multiply the 3 and the 2 outside, 3 times 2. 8 times 7 inside, 8 times 7. So it's going to be 6, and inside we have 56. You guys break down the square root of 56. So 56, yeah, let's go back. 8 times 7, that's it. 7 is prime, but 8, you can multiply 4 times 2. 4, you guys can multiply 2 times 2, and you guys can make pairs. So we can make pairs of 2's, and that's it. This one, you cannot make a pair. 7 is already prime. You cannot make a pair. So you guys are going to have your radical. The pair of 2 goes outside. There's only one pair. Remember this 6 right here, it's outside. You guys bring it down. So there's the 6 times. You multiply by 2. Inside, you guys are going to use the 7 and the 2. So you multiply 2 times 7. And you guys simplify. So the answer will be 12 square root of 14. So that is my exact answer, which is my radical form. Alright guys, I'm going to have to make another video, so make sure you guys check that video out, and make sure you guys practice, and I'll see you guys later.